Okay, now the following, the bits following this video uh, were recorded prior to now, before now, as I was doing experiments and collecting um, results from the experiments. Uh, so right now I'm going to go through and try to clean it up a little bit, cut out some things here and there. So it'll be fairly discontinuous, but I'll try to make sure that the fundamental stuff, the important bits are still in there. The very first section, which will follow this introduction bit right away, um, involves an actual crash, the only one that I was able to produce, unfortunately, and it happened almost instantly on the very first try. So luckily I got it recorded, and I really still haven't made much sense of how it occurred and what occurred, uh, and that's what multi-threaded debugging is all about. It's a very tricky business. Anyway, so I'll try and leave in most of that, even though there's a lot of humming and hawing and guessing and so on. You should see uh, just what a confusing mess a crash in a multi-threaded uh, scenario is to analyze. It's very confusing. You'll see that the crash is in a place that seems like it could never have occurred. Okay. Okay, well, it didn't take very long to produce my crash. To see how long might take. Uh, and the way I've got this set up here is using our once everything. Every now and again, at random, a random number of random strings is placed on the asynchronous print list, and once every another random range, I go through that, delete all calls. Now this may be the first time that was invoked. Sorry, and I may have gotten lucky, so I'm just recording the fact that I have this crash. But I want to do a few more tests, and if it was pure luck, then I won't have one to show you. But as far as the threads go, the one wherein the crash occurred is in the others are dequeuing thread or whatever, this thread. Okay, and it says it's doing an operator plus equals here. That's what it's trying to do. And now so that means it's making a copy of something, and which is calling now. Now a write string occurs in the same thread no, we're not adding any more. No, just What are we doing here? We're doing something. No, still adding. Allocate, allocate. And crash is here on right string. What's right string? Invoke. That's not one of my functions. Right string. Right. That's a CRT thing. So there's this invoke. They're all async. And then adding. Now it's a little bit confusing. see how these things are confusing. It looks like this thread crawl, okay, it's just adding something to the list. Now at some other point, there's writing, there's invoke, okay. Well, I don't see anywhere where it's calling right string. You know, oh, I see. Oops, I think I see. Invoke. Maybe invoke didn't complete. It should have called a function to like print TTS thing. Oh, I see. Okay, so it's no. Then that thing would still be waiting for the. You see that this is why this is confusing, because I don't see anywhere in here where there's any writing going on. Now it's true in the other thread, all those things were deleted. So it's as it's adding this thing to a list, it got deleted. Yeah. Oh, maybe it's just my debug printing. Where does that occur? There is no debug printing. What's the other thread doing? It's doing free. It's on this line, checking for a keystroke. No, it's not. Oh, wait a minute. Checking for a keystroke. That's going free. Free for what? Input record. Checking it. Okay, so it's creating an input record. So it must have gone through all this deleting. I'm not sure. Okay, this is this is why these things are difficult to debug, because while it may be true that I've gone and deleted everything, and this is trying to add to a list that got deleted, add something the list that got deleted, you would expect that if there's going to be a crash, it is going to be somewhere in here, but certainly not a crash in a call to print anything. And then you would expect that this one, if it was crashing, its crash would have been during this. So it's very difficult to debug these things. So now what I'm going to try to do is try to prevent this from happening at the same time that this happens, okay? And what I'm going to do is I'm going to try and do it without using any special operating system things or anything. I'm going to try just using a regular old Boolean. Like I'll make up a global Boolean saying that this thing is being used, and if it's being used, then this thing's going to have to wait. Okay? And similarly for the other guy. And it should still crash. And then I'll discuss why you can't just use a Boolean. Okay. So this is not done. An update. It certainly did get lucky that time. This has been running for quite a while now. With the using a very simple synchronization method. Oh, that other one, the right string. The mic. The right string. That right string, I think, had to do with writing something to here maybe. I don't really write anything there. I don't know. I'm still confused about that. Anyway, I just have a global Boolean, and if this Boolean is true, I sit here and wait until it's false, and then I set it to true, go through and do all the deleting, and then set it back to false again. And then in the other thread, I do the same thing. While the list is being accessed, wait, don't do anything. And then go and set it to true, add something to the list, and it's been running now for, let's see, last time it printed out its program time. Let's see, print out some. Every 10 seconds I'm printing the program. So actually, oh, there's 7 minutes. So it's been running now for 7 minutes with no real problem, it seems. Contrary to my assertion, I'm going to try and make it more likely to see a bug. Well, let's let it keep going. I could maybe speed things up by more frequently doing the cleanup. That's once every 3 to 4 seconds. And this is adding a bunch of things more often. You can see how often by that. Okay, I'm going to quit this. See if at least, if anything bad. No memory leaks, nothing. Works like a charm. Okay, don't need thread synchronization. No. Okay, well, I actually uploaded this video and then now I deleted it because I realized that most of the second half of this video was examining a problem, a memory leak that was occurring, and which I attributed to the problem of the mutual thread access. Turns out that's not the reason at all. There's another totally unrelated reason for that. So I'd like to be able to produce maybe another crash or some other problem with the way it's set up, and I can work on that. But there's a little bit at the end of this that I want to keep, and I'll upload this as it is, and so it's going to be much shorter, and at least you'll see why the whole method with the Boolean is wrong. It can never work. And that's really the main point of this video anyway. Okay, so I'll click out the rest. I'll add a little bit at the end. And I'll keep running the program, and sure enough, eventually something will happen. And then we can examine it. Okay. What I want to first just prove is that this global Boolean will not prevent mutual thread access from entering this function, which is what's causing the problem. Trust you can be sure of that. And that can be done quite easily because the debugger has a thing where you can suspend one thread and let another one run. But what I want to do is once I get here, okay, now I got my two threads here. Okay, now I can suspend these things. And what I want to do is I want to suspend this thread. Freeze. Is that the same as suspend? Yes, so. Okay, well anyway, it's not going to go, right? I'm going to run the program till I get here. You can't freeze it just yet. So, see, I've got to wait. Let's see, now these are all going to be waiting. Why is it here anyway at all? Oh, I know. Start the program. That thread is going. Okay. Now, what I want to do, put a breakpoint here. Now I want to suspend this. I don't know why it says freeze. And I want to have a breakpoint. I do have that. Okay. Now, this says false, right? So that means that I should be allowed to go in here. And the other thread, that's here. Right? They're both asking the same question. Can I access the list? Right? Now, now this says false, so that should bring me to this line. Okay? This guy's frozen. So, remember that a context switch can happen at any time. So what I'm going to do is put a breakpoint here. And now I'm going to force a context switch by freezing this thread and letting this thread go. Okay? This is still false. Okay? So now we've got both threads on this line. Now, you don't have to be a genius to realize that, first of all, both of these things are going to have access now to this list. It wasn't protected. Okay? The context switch occurred before I managed to do the assignment. So therefore, this thing, this test allows this thing to come in here, right? And now we have two threads accessing the same global object. So this Boolean test, because of the possibility of a context switch, is not enough to prevent mutual thread access to this global object. Okay? This sequence is not an atomic sequence of operations. Right? There's a comparison, wherever it is. Being accessed. Okay. Here's the test, I guess. Yeah. Okay. So there is some comparison thing going on here. And then the assignment happens on a different line. Meanwhile, a context switch occurred. I forced it to happen, but it's random, so it can happen. In this one, I don't know why it's keeping. I want to see this thread. Okay, same thing. There's testing, and then a bunch of other instructions, and then the assignment. So what we need to happen, if we really want this to prevent mutual access, is that the test and the assignment have to happen sort of at the same time. That is, you can't allow any instructions to get executed before the assignment occurs. So that's why these booleans are no good for mutual thread prevention. And that's really the main point I wanted to express here anyway. And we've seen the result. The result is we've got random behavior. I didn't get any more crashes, but our list got messed up. And we've had crashes before. And so this method doesn't work. It appeared to be working for a while, but that was simply pure luck. Okay. Eventually, that same thing would have happened. And eventually, we would have had a disconnected list, whatever it is, and the memory leak, and eventually a crash. Okay. Right. So now, how do we fix it? I'll get to that next lesson.